Hi, and welcome to the Unreal Engine News and Community Spotlight. On Tuesday, our summer UE4 jam came to a close, with over 150 entries coming in based on the theme, well, that escalated quickly. We've already started jumping into these submissions, and it's no surprise we've been blown away by the quality and creativity of the over 500 jammers. The work that goes into these projects is evident. Everyone who participated should be incredibly proud of what you've accomplished. We do have a tough job ahead of us, voting for the finalists, and of course, our special categories, Army of One, On the Go, and Something Something Reality. We'd also love to send a huge shout out to our sponsors for helping make this jam amazing. Keep an eye out on our social media channels for info on when we'll be announcing the finalists. Sam Dieter, a frequent guest on our stream, recently released an article about finding a balance between C++ and blueprints. This is a conversation that happens all across many channels, and everyone in the community has their feelings on the subject. Both methods have their advantages, and Sam walks through finding some balance between these two tools. Now, this is a cool event that we're getting behind. It's called Trojan Horse Was a Unicorn. It's a series of smaller events that travel around North America, Europe, and Asia, and this year it culminates in a massive event in Malta. Epic is signed on as a top sponsor for this Trojan Horse event, and members of the Unreal Engine team will be on the ground to meet with and share ideas with attendees this year. Each week, our amazing community jumps into the Answer Hub to provide assistance to others. A special shout out to our weekly karma earners. Everynon, Thompson N13, Mighty Enigma, Sevatar, Joachim Olsen, T. Sumasaki, Nebula Games Inc., Redbox, Eric Doublebore, and Manolo Nito. You guys are awesome, and thanks so much for everything you guys do. I'm really excited to share with you guys our weekly community spotlight. This first project comes from a community member by the name of Gothic Serpent. NeptuneGL is a fast-paced, three-dimensional space shooter with 6 degrees of freedom. As a spaceship, you must fly in all dimensions to attack and defeat other ships. This heavily sci-fi based space shooter includes realistic movement physics with a special focus on multiplayer. Be sure to check out the awesome work Gothic Serpent has put into NeptuneGL. Our second spotlight is called For the Love of Marius, Son of Rome, by Mamamon. A personal project, Mamamon has been experimenting with shading in UE4. I'm blown away by the extreme attention to detail and care he's taken with this project. It's spectacular. So very well done. And our third and final project is a really cool, really quirky game where you find yourself in a cardboard universe. Cardboard Wars is a third-person shooter in a world made of, well, cardboard. This action-packed shooter is a unique twist on a very familiar genre, allowing you to customize your cardboard warrior and join in head-to-head combat with up to 16 of your closest to cardboard compadres. This game looks like it's a ton of fun, and I can't wait to try it out. Thanks so much for joining us for the News and Community Spotlight. Hey everybody, and welcome to today's Unreal Engine live stream. I'm your host, Tim Slager, and I'm joined today by Nick Penwarden, the Director of Engineering. I almost said Technology and Engineering, but Director of Technology. Director of Engineering. Tim. Hi. And Pete Sauerbray, one of the senior programmers here at Epic. So thanks so much for joining us today, guys. We're going to be talking about some of the mobile optimizations and things that we've been putting into Unreal Engine, correct?
Mm-hmm. Yeah, we thought this would be a good time to talk again about mobile and UE4. Obviously, we've done a lot of work recently, particularly on Fortnite, to get it shipping out first on iOS earlier this year, and earlier this month we started the Android beta for Fortnite. In the process of making that happen, we've had to do a lot of optimization into the engine for mobile, as well as adding new tools and just fixing a ton of bugs and different optimizations to make that all possible. Most of the work that we did initially and everything that we did to ship on iOS, that made it out in the 420 version of the engine. But we've been working really hard over the last couple of months to improve things further, get Fortnite ready for Android, and all of that work is going to be in the 421 release coming out.
That's awesome. We've done a couple of streams on like proxy LOD, and I think people have really enjoyed kind of just what that brings to the mobile experience. So I think this will be a great stream. So if you want to dive in, and by all means.
Yeah, sure. So I guess to set the stage first, it's probably important to talk about the kind of problem we were trying to solve with Fortnite in particular. with Fortnite, we were looking at bringing the entire game itself with full crossplay to every device. So we needed to make sure that if you're playing on an iOS device or an Android phone, you get the same experience, and you can play against the same players playing on PlayStation, playing on Xbox, playing on PC. And in order to make that work, that sort of constrained how much we could try to change the game on mobile. So,
Right.
If something affects gameplay, we need to be able to render it if a player can hide behind it, or if you can see a building that somebody can shoot you from, you need to be able to see that building and see
Right.
that player. So typically on a mobile game, you try to scale down how much you're drawing, and you try to scale down how far you can see and stuff like that. And we couldn't quite go all the way with Fortnite because of that. So that really forced us to find ways to optimize the engine itself and give us better or sort of different scalability knobs. So, one example you mentioned, proxy LOD. We're using that across platforms to be able to view points of interest like, tilted towers and so on from very, very far away. We can take a whole bunch of meshes and make a proxy mesh that approximates, what that point of interest looks like. But for mobile, we added a bunch of other features to the hierarchical LOD system. So you can set it up to take a bunch of meshes and just grab the minimum LOD and jam them together, and then rebake a material that covers just those. And so we use that on Fortnite to be able to take something that you could see up closer than the HLOD itself, which might cover up windows so you can't see inside the building and is very, very low resolution, and give you something that is much better looking visually, and gives us some flexibility in terms of we can create a material that can then go in and support the destruction bits in Fortnite. So if you destroy a wall, we can go and collapse the vertices of that wall in that combined mesh. So kind of some additional features that we needed in Fortnite that gave us some flexibility that hopefully others can use as they're making their mobile games in Unreal.
How long have you guys been working on some of these mobile optimizations?
I think we started working on these late last year. The big push really began at the beginning of this year, around January, is when we did most of the work.
That's awesome. Yeah, I know a lot of people have been starting to dive into making a lot more mobile games, and so some of these really new tools are kind of making that easier for them to, especially with phones getting bigger and other operating systems taking up more space. You need to take all you can for your game, right? And
yep.
So
yeah, absolutely. And so a lot of those features that I was talking about, we gave a technical presentation back at GDC on a lot of the engine improvements that went in that time frame. So definitely go check that out if you want more information on all of those bits. One of the things that Pete and I thought would be interesting to talk with you all about are some of the tools that we use sort of as we're ongoing, adding more content, adding new levels. Well, not really new levels, but new points of interest into the map. The map is constantly evolving. How we monitor performance, how we monitor memory, how we optimize perf and memory to try to fit on new devices. And I guess actually, maybe we should start with memory because it's one of the biggest challenges that you're going to run into trying to get a game onto a phone. So before Pete dives in and gives you a deep dive on some of the tools that we use, some of the constraints, even on phones that have, so if you take a look at iOS, you typically have 2 GB phones. You've got some phones with 3 GB. These are usually the plus version, so 7 Plus and 8 Plus and the iPhone 10. On those devices, on 2 GB devices, you really have, 1.3, 1.4 gigabytes of memory to use, somewhere in that range. Because you got to leave some room for the operating system and the background apps, and if you receive a phone call, it's very important you actually receive the phone call. So the OS
my kids would differ with you. They would argue that's
text message.
Yeah, maybe text message.
Yeah. And
Instagram, whatever. They need all of those things.
Yeah. On an Android phone, it's the phones tend to have more memory, but the apps and the operating system tend to use a little bit more of that memory as well. So on a 4 GB phone, you're really looking at trying to stay around 1.2 gigabytes of memory used. And that's actually that's been by far the biggest challenge in us getting the game out on Android, is getting our memory usage down to the point that we can run really well across a broad range of devices. So, yeah, Pete, do you want to talk about some of the tools and how we approach memory tracking and optimization?
So the biggest thing we have with Fortnite is it's being developed cross-platform. So
Right.
everything we kind of do for PC, Xbox, PS4 kind of slides downhill onto mobile as well. So for instance, if we're making a UI or the front end for PC and we do some optimization on PC that seems logical for a 16 gigabyte PC, sometimes that doesn't fit very well on your mobile device where there's far less memory. So one of the ways that we kind of go and try to track some of those sorts of things is the console. When you bring up the console, there's several commands that we have that you can use. Things like stat FPS or the various stat commands that you have on the console. But there's another one called obj list, space list, and that will give you basically a rather a long list of all the various classes of objects that you have in your game currently loaded, and along with a breakdown of various pieces of the different types of memory, like resident memory, disk memory, that sort of, or disk space that it uses. Those sorts of, and object counts, which is actually also very important. So from there, you can get a nice overview of where your objects are, what classes are taking up the most memory, and in general where your game is heavy on various objects. Like for instance, on iOS, typically most of our memory is in texture memory, but because we use PCM for our compression type for audio, we actually have a very large audio footprint as well. And you can see that directly in that object list. Now, the nice part about that is once you have that list and see where the heavy parts are, you can then do obj list class equal, and then you find one of those classes that were in that list that was one of the big ones, like texture 2D, for instance, and then run that list again, and now you have a list of all the individual objects along with their memory and how much they're taking up. And that then allows you to go through that list and go and say, hey, why is my reticle texture 4K? Why is it a 4K texture? I'm on a smaller device. I'm never going to see all that. Can I make it smaller? Or better yet, going back to kind of the UI thing here, why are all my front end textures in game, eating up memory that can be used for other things like the world? So being able to track that sort of stuff down is sort of a first line of looking through and, hey, what's there and what's not there, or what's there and shouldn't be there, or why is this particular object so large, this texture so large. So that's a good first point to kind of go through. My biggest mantra for this whole project has been, if it doesn't belong there, why is it there? Can we get rid of it? Because the best optimization is it's not there at all optimization, because you're going to get 100% back from that particular guy. Barring that, then you can look at other things like, hey, in the case of the textures, what's streaming versus non-streaming? So if you have a streaming set of textures, you have your texture pool that's streaming. You're going to have some textures in that texture pool that never stream, things like UI again. So it's always a good thing to make sure your UI is as small as possible. Various other things, like we have terrain, landscape in Fortnite. So in that particular thing, there's things like terrain height maps, terrain weight maps. Those don't stream because they're needed most of the time. So that was an area we looked at as well, found out that they were all uncompressed, and on mobile we now compress them. I don't know if that made it to 420. That's actually a relatively recent thing because we did that for Android, but that'll probably be in 421.
Yep.
So there's now an option in Fortnite that will make it to 421, which is basically the ability to say, hey, I want to compress these terrain weight maps. Doing that, we saved a lot of memory. We saved about 15 megabytes, something like that, which was over 90%, with very little difference in quality of the actual terrain and the weighting of the various landscape layers. So that's one thing we looked at. Another thing, especially for Android, is we compared Android versus iOS on these sorts of things, on these lists, and go, well, why is Android 3 or 4 times larger than iOS. Well, that led to the fact that originally we were using ETC2 as our texture compression. So for those of you who don't know, Android has like 6 different compression types that are based on what the phone supports. So the the lowest form of that is ETC1, which basically will compress color, and that's about it. It doesn't compress alpha. If you have alpha in your texture, it will leave that uncompressed. Then there's ETC2, which then basically came and allowed you to start compressing alpha. It's kind of similar to DXT in some ways, which is also another form of texture compression some devices support, as well as ASTC. In the end, ASTC is a better compression format for us because we can pick the different levels of compression. So we can, instead of saying like DXT where we want to do a 4 pixel block, we can do a 12 pixel block or a 6 pixel block or 8.
It gives you more options.
Gives us more
to
options,
compress.
so we can compress more if we need
Right.
to. So for Android and iOS, we actually use an 8x8 block now. Now on Android, we were doing that from the beginning on iOS for our diffuse textures, and a 6x6 for our normal maps, so we can have some of that sort of stuff. That was a pretty big savings on Android because ETC2 is only like a 4 times compression. An 8x8 ASTC is a 16 times compression. A 6x6 is, I don't remember, probably about 8 or so, something like that. So that dropped our texture memory quite a bit, allows us to drop our texture pool size for our texture streaming, which again gains us back memory.
While still maintaining the visual fidelity of the
Yep.
textures.
Correct.
Yeah.
The next thing, another thing we were looking at, more for iOS than Android, is like I said before, iOS uses 80 PCM. Turns out that for some of our stuff on 80 PCM, when we looked at the various the sound sizes, we were wondering why they were again so much larger than Android. Turns out that Android was defaulting to a lower sampling rate, which meant that in general the sounds themselves even started off at a smaller size than they did
Right.
on iOS. A simple change on iOS to make it do that, and suddenly we got back. Normally we were running at about 100 megabytes of sound memory. Now we're running at about 70. So rather large reduction just by going back and saying, well, why are we using this sample size? Similar things for like looking at meshes and when you do object lists with skeletal meshes and static meshes and that sort of stuff, you can start to look at, well, why is this particular mesh so much larger than the rest of them? How many vertices does it have? Does it really need that many vertices? Can we bring that back down?
Right.
That led to some of the stuff earlier, back in January, where we decided that we really didn't need LOD 0 on mobile. It was it looked really nice, but it was pretty large, eats up a lot of the memory that we have. So we basically added this feature that allows mobile to, in essence, cut that one out during the cook process.
Yeah, and I think one of the things with OBJ list is it can give you artist actionable feedback. Like that's the most important thing you really get out of it is, so when you do an OBJ list of skeletal meshes, or you do it of static meshes, or a similar command, list textures will kind of give you sort of like OBJ list for textures, but has even more information in it. That's the type of information that then you can pass off to a good technical artist who can, okay, I'm going to sort all the meshes by the number of vertices that they have and which ones are, where are the outliers? Why does this flower pot have 30,000 vertices? That doesn't seem very efficient.
complicated
So
flower pot.
yeah. So go
Sure,
in
it's
and
beautiful.
optimize that one, or create an LOD.
Right.
You can identify which meshes don't have LODs and make sure that they all get LODs and stuff like that.
Yeah.
Being able to take the data and turning it into actionable feedback for the people making the content for the artists is really, really important.
So is that how the workflow goes? Is the technical the artist will make the things, it'll go through programmers, engineers, optimizations, and then you guys will send it back and say, hey, we need to do this to reduce.
I mean, generally, the artists sort of have a content pipeline in terms of when they're making content, they know, okay, we've got to create LODs, and basically the engineers have already worked with the art leads on the project to say, here are our budgets. Here's what we're aiming for. For LOD 0 should have about this many verts, and LOD 1 should have about this many verts, and so on. And so with that kind of in mind, the artist will go in and generally make content within those constraints. So there's a little bit about catching things that slip through the cracks, as
Right.
well as, maybe some model was created 4 years ago or 5 years ago before we were really looking at mobile and had these constraints in mind. And so being able to catch those when they make their way into the game and make sure that we go and fix them up.
Yeah, and there is a feedback loop in some sense because we're constantly updating the map. So we have performance QA and things like that that are running various automation tools to give us the newest update every time we have a release, so that we can make sure that, hey, when for instance, a good example of this is when the comet hit and made Dusty Divot.
Right.
Originally, Dusty Divot was actually a much larger crater, but via going back and forth through the various tools and doing our NSense Profile Go is a way we can quickly go around the map and get things like object lists and memory dumps and things like that. We determined that because it was so large, it was a POI that was so large that it wouldn't actually leave memory in time for some of these other large POIs.
Oh,
so
okay.
that feedback went back to the artist saying, "Hey, we gotta make it a little bit smaller so that the POI itself would leave memory by the time we get to someplace like Tilted Towers, for instance."
So by the time you move away from that object's.
Yeah.
Gotcha.
So that's part of that feedback loop.
Yeah. That's cool.
But for the most part, yeah, we have budgets set up front.
Yeah.
Yeah.
That's awesome.
One of the other memory tools worth talking about is something called LLM, stands for Low Level Memory Tracker. And the goal of LLM is really to count every single byte that the engine allocates so that we know exactly where memory is going. It only tracks high-level categories of memory, so it'll track texture memory and static mesh memory and skeletal mesh memory and so on. That's useful for a couple of reasons. One is it's really efficient to track, so as we're doing performance runs, we can basically save out that data during a normal gameplay run and then take a look at it over time. We can look at sort of graphs of what does static mesh memory look at over time, and there was a spike here, what's going on there? Maybe that's when the player went into a certain POI. Let's go take an OBJ list from that area, figure out what all these static meshes are. We need to get that memory down. It's also good for looking into memory that code is using. So for instance, we can track sort of the amount of memory that materials are using and material instances are using. And some of that is driven by art, some of that is driven by code. And we were able to use that to realize, hey, we use a ton of materials in Fortnite, of course. But we use a ton of material memory. And so given that we took the opportunity to look into where we can shave a bit of memory on the code side, anything we can remove from one material, if we can save, just on the order of 100 bytes, 200 bytes, we're talking about saving megabytes over in Fortnite. So that becomes valuable. One of the other things that actually LLM is pretty good for is being able to quickly identify that there's a memory leak in one of those buckets, and then you can kind of start drilling down and use other tools like Memory Profiler 2 or even OBJ list potentially, or platform-specific profilers to try to figure out where the actual leak is. But we actually recently identified a leak in the material system. So there were some material resources that were not getting correctly freed. And so looking at a chart of LLM, you can just see that material memory constantly increases, it never goes down. And that's the sure sign that you have a memory leak. Yeah. So it's been really useful for that. One caveat with LLM, I mentioned that we try to track every single byte the engine allocates. On consoles, this works really well because we allocate everything. On PC, on Android, on iOS, it's not entirely accurate. We tend to make some approximations, mostly where it involves the system level APIs, especially the graphics API. So if we're going to create a buffer, we know how much memory we're allocating for the actual vertices themselves. We don't know what kind of bookkeeping information the driver is allocating. We don't know what other sorts of allocations they may or may not be making under the hood. Maybe there's a shadow copy of the data. There's all sorts of, we don't necessarily know that, and so we can't account for it. And so when we look at what the system is telling us we're using memory-wise and what LLM reports, that delta usually means we have some sort of misaccounting in terms of what the system is allocating on our behalf. But even then, it's useful information. So, for instance, on Android, one of the things we've been working on a lot over the last several weeks is shader memory, and basically what we were seeing is we have a large discrepancy between Android is telling us, hey, you've allocated 2.3 gigabytes of memory, and LLM is saying we allocated 1.2 gigabytes of memory, and so now we're trying to figure out, well, where did this other 1 gigabyte of memory come from? That seems crazy. And based on experimentation and comparing how different devices were, how much memory they were using, what we were able to figure out is that the driver was allocating a lot of memory on our behalf every time we went and created an OpenGL program. And this led to us being able to identify a couple of optimizations. One was just a pure win in terms of memory. Yeah. So I can explain that one in a second. The others have really just been, how do we reduce permutations, lower the number of shaders we use. We added a least recently used cache, so we can kind of try to cap the amount of memory we're using at the cost of some additional CPU work. So if we delete a program to free up the memory, and then 10 frames later we need that program again, we have to go and create it. And that's going to cost some CPU work, but allows us to keep our peak memory lower, which can be much better for performance, and can help prevent us from getting evicted, which is really important. You don't want the game to basically crash.
Yeah.
Yeah, I don't think nobody likes that. I don't
No.
That's
So yeah, I guess just like interesting aside on that one memory optimization was we have a path in our OpenGL renderer where we can emulate constant buffers. So usually with constant buffers, we have all of the constants that a material wants, all the constants that our shaders want for lighting information and transforms and stuff like that. And we just stick those in a constant buffer or a uniform buffer in OpenGL terms, and the shader references that. It turns out that in OpenGL, because you need to be able to query a lot of information about the layout of those buffers, so the driver ends up tracking a lot of information about the size of them, what the offsets are for the individual members, and so on. I should say this is kind of speculation about where I think the memory is going, but I'll explain why we think that in a second. So we suspect that there's a lot of memory going to that. We have a path in the driver where we emulate constant buffers. So instead of creating real constant buffers and referencing the constant buffer in the shader, we just sort of flatten out all of the constants that a shader actually needs. We have a single array that the driver knows about, and then the engine will manually grab data out of those buffers from at the engine level on the CPU, put them into the array, and the GPU will just pull from that array. So basically, we keep the mapping table of how we take data and move it into that buffer rather than baking it into the shader. And it turns out that alone saved several hundred megabytes of memory without removing any shaders. And so the expectation is that just removing all that information about all of the individual symbols from within the constant buffer and going to a single array saved us a massive amount of memory.
Yeah. So I got a couple of questions if you guys want to from the community real quick.
Yeah, sure.
One is what is easier or better? What would you suggest as far as making the game? Would you start with making it for mobile and then scale to other platforms, or would you do it the opposite way, where you're building two consoles, PCs, and then port to mobile? Not a hard question.
Yeah. I mean, I will say it's always going to be easier to scale up. However, that said, I think you're probably better off if you know that you want to target all of the platforms. What you want to do up front is get the game running on all of the platforms and keep an eye on everything as you're moving forward. I think if you start and make a full game for console and then you want to bring it to mobile, which is what we did with Fortnite, you're going to have this dedicated effort of, okay, we have this game.
Right.
it fits on console. How do we make it fit on mobile? How do we shrink it down? If you make it on mobile and then bring it to console, you're kind of going to have
You have a lot more playroom, right?
yeah, you'll have something that fits on mobile. If it fits on mobile, it's going to fit on console. But now you have to figure out, well, how do I go and improve the experience? How do I make it better? If you have to go in and add new higher LODs for all of your meshes, you're basically going and redoing all of your content now, rather than trying to take content that you made and simplify it, which is a lower, which I think is going to be a bit of an easier process. So
They both have their challenges, it seems.
that's right.
Yeah.
Yeah.
So-
I think your best bet is to really try to get it running on both and make sure you understand the
It's a-
trade-offs.
It's also, if you know you want it to run on all of these platforms from the get-go, it's going to be easier than if you did what we did, which is made a game for multiple years on PC and console, and then at a certain point decide you want to make it on mobile. At least if you know you want it to work on all these platforms from the get-go, you can at least start planning for it right away. So when you plan out your content for your Xbox or for your PC, you know right away that, hey, you're going to want to make sure that you've got this nice high-res model, but you're also going to need lower-res ones to go on to, not only for LODs, but also to go on to mobile. So so knowing it ahead of time is certainly going to put you ahead of the game, for sure.
I will say the other thing that will really help is if you approach developing your game from a PC mentality of you need to build scalability in your game. You want players who have a 1080 Ti and 64 gigabytes of memory
Right.
and an i9 crazy CPU to have a really high-end awesome experience. And you also want people playing on a laptop with Intel integrated graphics and 4 gigabytes of RAM to be able to play your game. If you have to scale from a high-end gaming PC to a laptop already, that's going to make your life a lot easier when you go and want to bring your game to say iPhone or Android. Especially, phones are actually really fast these days on the high end of things. If you take an iPhone 10 or an iPhone 8 or the Android Note 9 and compare it against a laptop PC, it's not some order of magnitude difference in terms of the type of performance you can achieve.
So we talked about the difference between 1080s versus Intel integrated graphics. With Android, I know iPhone is iPhone, right? You can't get with the different varying Android devices. Do you guys have to consider all of those different kind of devices when you're making Fortnite on the mobile or any mobile game?
You do, yeah. And that makes it much more challenging, I think, than trying to ship on iOS, where you pick the generations you want to support, and you're kind of scaling across a relatively fixed number of phones. Android is a much broader ecosystem, and so you kind of have to approach the Android ecosystem a bit like some combination of PC and iOS. So PC from the sense of you're going to have people playing the game on a phone that you didn't have an engineer in-house looking at and optimizing. You're going to want to make sure that your QA team and so on are testing the game across a massive number of phones, but you yourself are not going to get to personally look at every single device. Whereas, between Pete and myself and the others on the team, we looked at every single iOS device before we shipped on iOS.
Yeah, it's a lot harder to do that with Android.
Much more reasonable.
Well, you also get into iPhones, iPads, iPad minis, and those. Do those have varying degrees of power? Correct.
Mm-hmm.
They do. I think. I mean, the difference between iPhone and iPad tends to be more about the resolution you need to render at. So it's such a large screen, you actually have to render at a higher resolution, where you can get away with a lower resolution on something like an iPhone because the screen's relatively small.
And the other thing to think about here is that, I mean, we're supporting, at least for Fortnite, we're supporting iPad minis and iPhone 6s and things like that, all the way up to the iPhone 10 and iPad Pros. That's really only about 3 or 4 chips. So like the A8s all the way up through the A10s that they now have.
Right.
So it's not really that much different in the ways in terms of hardware. Whereas on Android, I mean, you can be looking at different 3 or 4 different types of Adrenos alone, or
Yeah.
2 or 3 Mali chips, or just all the plethora of different
Right.
hardware vendors that are out there for the different phones.
Yeah, broadly speaking, I mean, we're talking about on Android we have 3 different generations of Adreno that we're primarily targeting: the 530, the 540, and the 630, with some of the variants in between, being supported, and then similarly Mali, so this entirely other architecture
Right.
that we're supporting, and again, like 3 different generations of that with the G72, the G71, and the
Right.
T880, I
Yeah,
think.
something like that.
And so 420 has brought in a lot of new features, especially for mobile optimization. So it sounds like there's a future in mobile optimization as well.
Mm-hmm.
So we're going to be adding more things, and as we figure them out for.
Oh, absolutely.
Yeah.
Um,
And remember, I talked about switching to ASTC for Android.
Right.
It's one of our optimizations. The reason why we held out for so long on ETC2 is that format actually supports pretty much every single phone that's out there for Android. So
Right.
at some point, we want to try to go back and support some of those other phones, which means at some point we won't necessarily get that optimization that we got, the texture memory optimization, because we're going to have to drop to something like ETC2 or DXT. And so we still have to find memory in other places so we
Gotcha.
can support some of these other phones.
Yeah, and we're also another area that we're working on very hard right now is Vulkan and improving our support for Vulkan on Android. Right now, we only have Vulkan supported on the highest end Adreno chips, and only when we have 6 gigabytes of memory. And part of that is when you're writing the Vulkan RHI in our terminology, but the Vulkan renderer, you're kind of writing a driver yourself, and so the way you handle certain, say the way you manage descriptor sets, or the way you manage heaps, and the way you're managing PSOs and so on, actually needs to be a little bit different with each device to be optimal.
Mm-hmm.
And so we focused on the Adreno chipset and trying to make that as good as we could. We shipped that to start getting some data and start improving on it. We're currently working really closely with our friends at Samsung, who are helping us with Vulkan optimization, especially looking at actually memory optimizations with Vulkan, so that we can support it on 4 gigabyte Adreno devices. And then as we continue to optimize and improve performance, we'd like to roll it out on the Adreno 540 and as well as the Mali chipsets.
I gotcha. So with all these mobile optimizations, and this is kind of a question from the community, are a lot of these mobile optimizations also, would they also support functionality for mobile VR projects, like the Gear VR or anything like that?
I mean, yeah, everything we're doing applies to mobile VR as well. Mobile VR just has the additional complication of you need to aim for 60 hertz, and
Right.
you need to do it in a way that you're not going to be utilizing 100% of the device. It's kind of something that we didn't touch on too much
I was
yet.
going to say, this is a good segue into just performance.
Yeah, but when you're making a mobile game, the one of the challenges that we faced is on like a console, you can't just max out the CPU and the GPU every single frame. When you're profiling on an Xbox or a PlayStation, you just want to make sure that all of your threads are not taking more than, in our case, 16.6 milliseconds, and your GPU isn't taking more than 16.6 milliseconds, and then you're done. You don't have to worry about sort of the dynamic conditions of, well, this user might be running other things on their phone.
Right.
When we're using more CPU, that's generating more heat, which means that the clock frequency will go down, which means now we need to actually, our frame times go up, and so if you needed to peg the CPU to stay running at a solid 30 on a phone, then eventually the heat is going to go up, the clock rate is going to go down, and you'll no longer be making frame rate.
Mm-hmm.
And so for that reason, you kind of need to approach performance a bit differently. What we found worked really well, in particular on iOS, was targeting 60 frames per second in sort of when you're just exploring the environment. So when you're on an iPhone running around the map in Battle Royale, we're actually able to complete CPU rendering, GPU rendering, and game simulation all in 16 milliseconds. And the reason we do that and don't just start running at 60 is because that allows all of those threads to sleep for about 50% of the time. And because they're not doing work half the time, the device is able to sort of keep cool. We're not expending, or we're not using a lot of battery life, which is another thing that's really important. If you're on, on the bus on the way to work and your phone dies halfway there because we're just chewing through the battery, that's not a fun experience either. And that also means that when things kind of start to heat up, when you get in a big battle, when you're in the middle of the action, we can scale up performance and start animating more characters, rendering more characters, and playing more effects and stuff like that. And at that point, we might be getting closer to running at 30 millisecond frames. But then when things cool down and you're back, hiding in a bush in the corner, we can drop back down to 60.
Is that your tactic as you hide in a bush? Just wait?
My tactic is to hide.
Yeah, it's a good tactic.
That's
so
always my tactic.
I hide in trees.
Yeah.
People don't tend to look up. Like with Thanos, I was hiding in trees as
Nice.
Thanos, just waiting. So
It's a good plan.
Yeah, it didn't work out too well. So heat is obviously something that you have to consider when talking about mobile. It's something you have to be concerned with. I personally play with my phone plugged in. Do you think that's a bad idea, considering that's adding heat to the device?
It does add some heat. It's not necessarily a bad idea. Some phones actually allow the device to run a little bit at a higher clock rate when you have the phone
Gotcha.
plugged in, actually. So, it's actually...
So for
actually fine.
testing, it's not necessarily a bad idea if I'm making a mobile game to leave my phone charging while I'm I'm testing it out. Okay.
Yeah,
I mean, and for iOS and stuff like that, if you want to do any kind of debugging or anything like that, you have to have it connected to your computer anyway, so it's already just charging.
Perfect.
Yep. And of course, where there are also all sorts of other dynamic conditions with something like a phone. So a lot of people have cases on their phone, and
Right.
cases make it harder for the phone to dissipate heat. And maybe you're outside and the sun is blasting down on your phone, so that thing's
Right.
going to get really hot versus sitting in an air-conditioned office.
Yeah.
That's I would never have thought of that. Well, making a mobile game, like, hey, if I'm
Yeah.
sitting in the sun, it's going to
Yeah.
slow down potentially the device. So
Yeah, I mean, potentially you have other apps running on your phone in the background. Some
Right.
some are more heavy than others. Like Facebook tends to be a pretty big hog of background things. Or let's say you run Spotify or something like that, which is streaming
Right.
music at the same time. So that's going to be a pretty big
'cause
user.
you're also using your wireless data.
You're using the wireless.
your
Having that
antennas are
wireless
going,
guy
yeah.
on is pretty heavy for the battery.
Okay.
So
Yep. Yeah, and I guess kind of, like P said, it's kind of a good segue to talk a little bit about performance and how we track performance, some of the tools in the engine for doing that. So what we use a lot with Fortnite is CSV charts and FPS charts. So you can do this with like stat start FPS and stat stop FPS.
yeah.
And what this allows us to do is basically the engine will track some sort of key performance metrics while the game is running. It'll track thread times. It'll also track, there are different CSV profile stats defined in the engine. So like just overall tick time for the world, how much time you're spending doing stuff like updating the HUD or animation, stuff like that. As well as different aspects of rendering, tracks draw calls, time spent in the renderer, time spent in shadows versus base paths and stuff like that. What we can then do is we take that that just saves out a CSV file, so a giant spreadsheet of what were all of those times every frame. So you can chart those out over time. You can calculate metrics like the metric we use most is something called MVP 30. So missed vsyncs as a percentage, and basically what we're trying to figure out is how many frames did we drop. So did we drop a perfect run where we didn't drop any frames? MVP will be 0. We will have rendered out, for every second the game was running, we will have rendered out 30 frames. So take the total number of seconds the game was running, multiply by 30. We should have rendered that many frames. And then usually you're going to drop some frames during the course of the game, and how many did you drop as a percentage of the total play session is something that we use a lot.
Is 30 kind of the baseline for that, where you measure from, or let's say I want my game to be at 60 all the time, do I just...
Yeah, if you want your game to be
measure
at
out?
60, then you would use, we call it MVP 60.
Okay.
So
But that system is already in place for that condition. Gotcha.
Yep. Yeah, and so we usually aim for around 1 to 2% dropped frames is fairly reasonable.
Yeah.
But yeah, since this is a CSV chart, you can basically go and graph the whole thing out over time. You can take a look at it and identify what was going on near the end of the game or at the beginning of the game where we were not maintaining frame rate, and it looks like it was rendering or it looks like it was game. If it was game, then you can go into the game breakdown and was it animation or was it particles or stuff like that. Start kind of trying to break it down a little bit. Again, like LLM, this kind of gives you a broad idea of where your time is going. Once you've identified something that you need to drill more into, then you need to start looking at sort of deeper analysis, like the UE4 stats profiler is a good one where you can take a look at all of the stats, so you see all of the blueprints that are ticking, all of the game objects that are ticking, all of the individual animations, stuff like that.
When would you recommend that people do this? Midway through the project, if you put in a big feature, where should you be checking this out?
In terms of tracking performance, you should be doing it the entire time you're developing the project. So basically, you stand up the project, you have your test of here's how I want to test performance,
Right.
And you should be tracking what performance looks like across a gameplay session from the beginning. That way, you can identify regressions of, wait a minute, yesterday everything looked fine, and today we're not maintaining frame rate in the beginning of the game or the middle of the game, something like that, and then you can take a look back, well, what went into the game today, right? And then use that.
Let me stress this again. Do this as soon as you can. The number of support requests we get that are, hey, I'm going to try to ship my game tomorrow and I can't run on iPhone 6S.
Right.
It seems to crash with no warning. And then you ask the question, well, have you been running it on that during your entire development process? The number of times I hear, no, we just tried it for the first time yesterday, is far too many. You really need to do it from the get-go as much as possible.
Yep.
So let me stress that again.
Yeah. One of the other sort of tools in the engine that's really really helpful for this is the replay system. Now this does mean that in order your game has to support replays, so as you're building the game, you need to build it with replays in mind and networking in mind, because the replay system is built on top of the network replication system. But if you have a multiplayer game or you've built sort of a local game with replication in mind, being able to use the replay system to record out what the gameplay session, or to record out a gameplay session, and then run that over and over again, is really good for tracking performance over time. You can track, you can A/B test optimization, so you can go in and say, well, what would happen if I make this code change here, or what would happen if I disable shadows or disable particles for this run. Rerun the replay, see what everything looks like, and you can get a good feel for how much that optimization would save or how much time you're putting into a particular area. It can really drive where you want to spend your time optimizing.
Gotcha. That's cool.
Yeah, and once you have that overview, as Nick was trying to say, you try to dive down deeper into the thing. So there's usually, for instance, like on consoles, you have console-specific performance analysis tools. For mobile, for iOS, there's things like the instruments. Thank you. The instruments profilers. We've also integrated some third-party tools for this sort of thing, FramePro and that sort of stuff. So that those are some of those are going to be sample-based timings, and some things are event-based timings. So you just need to be a little bit aware of that. But those are allow you to deep dive into various problem areas and try to figure out exactly what's really causing the problem.
Gotcha. That's awesome. Somebody asked, and this is probably a little more specific, would you recommend locking all devices to the same frame rate? So let's say I'm releasing a project on Android and iOS, and obviously, maybe I have the newest, latest, greatest Android device, and it's more powerful than, say, the iPhone. Would you lock your frames across both at 30, or would you recommend people kind of let the higher performance?
So that's it's gonna depend a little bit on your game. Generally, I would say you're gonna want to make that decision per device. So on Fortnite, we're currently across all of iPhone, we're locked to 30 frames per second. On Android, Most phones are locked to 30, but actually the lower end phones we lock to 20 by default, because having a smoother play experience at 20 is actually better than having a choppy play experience at 30.
Right.
And if you take a look at some of the higher end phones on Android, some of the higher end iOS devices, there's the potential with some optimization that we're working on that, maybe one day those could run at 60, and that's absolutely something that we'll be looking at.
Yeah, and also remember, as we talked about earlier, I mean, if you run it full out at 60, potentially you drain battery faster, you heat up faster, that sort of stuff. So having it at that 30 frames per second is usually a good place to start, so that you can make sure that your battery is going to be okay, you're not overheating and that sort of stuff. Also, the other thing to look at is with those higher end phones, you can turn on other features and still maintain the 30 frames per second. So, you may turn on more cascades for shadows, or you may turn on, higher fidelity animation, or more particle effects, or GPU particles, or that sort of thing.
There might also, I would also say, on Fortnite, we've exposed the option to the user. So do you want to lock at 20? Do you want to lock at 30? Maybe one day, do you want to lock at 60 on mobile? Certainly on PC, all these options are available. You can VSync at 120 or 144, or just not VSync at all.
240.
Yeah.
Messes with my eyes.
And I think it's really nice for users to have that option, especially on mobile, where I might actually want to run at a lower frame rate because my battery's getting low, and I want to extend battery life, and I still want to play the game, but I don't need super smooth frame rate right now. I don't need to run at 60. Or I'm at home, I'm plugged in, I don't care about battery life, I really want the smoothest experience possible, so let's crank it up to 30, 60.
All right. Trying to see, I don't see any other questions coming in. So if I'm a new mobile developer, is there any advice that you would give me when using Unreal Engine to optimize my game for mobile?
I guess one of the big things up front is start thinking about and tracking draw calls early. One of the biggest performance bottlenecks that you will hit on mobile is purely the number of objects you can draw every frame. A PC, a console can generally chew through many, many more.
Right.
Things are getting much better on mobile, particularly on iOS. Metal is quite efficient these days, and so you can push a lot of draw calls on Metal as well. Vulkan, I think, will get there on Android, but it's that's really only going to be for the highest end phones. So, you're talking about, whereas on console, hey, a couple thousand draw calls, no big deal. On Android, for instance, depending on how far back you want to go, you might be looking at, hey, we need to fit within 400 draw calls in order to run on a 4-year-old device. In order to run on a 2-year-old device, maybe you can afford 500 or 600 draw calls. And so you're talking about just a couple hundred draw calls. You need to be really efficient with where you're spending that performance.
Gotcha. Yeah, and as I said earlier, I mean, if you're going to target multiple devices, make sure you run on the lowest performing of those as early as possible.
The weakest link.
The weakest link. I mean, because if you've been running that iPhone 10 for 6 months and then suddenly try your game on an iPhone 6, you might be surprised that it runs poorly. It maybe even runs out of memory. Those sorts of things. So you need to make sure up front that what you're targeting you are running on.
Gotcha.
And so, lowest common denominator is usually a better place to start from, and then build up towards. For mobile.
Phones have been getting a lot faster, very, very quickly. So the performance of an iPhone 10 versus a 7 versus a 6 is just, the 10 is orders of magnitude faster.
Yeah.
And so you need to account for that type of scalability between the two devices.
Gotcha. Okay. So I have another question, and I'm going to read it verbatim from the chat, and it is: do some of these optimizations carry over to WebGL, and is there any news on reflections in WebGL?
So let's see. Does it carry over to WebGL? I think the general advice carries over to WebGL.
Right.
A lot of the optimization work, some of it which went into OpenGL will help WebGL. But some of the, so like you mentioned the emulated uniform buffer optimization, WebGL was already using that because it uses ES2 level
Yeah.
APIs.
Some of the higher level things we've talked about, things like, you know, dropping LODs and things like that during cook will help for sure, because those are in essence cross-platform. You could use the same thing on consoles if you wanted to, but things that are specific to like OpenGL, probably not as much, just because it's ES2 based, and most of the things we've been working with for Android are ES3 through 1, I think.
Okay.
So
Awesome. Is there anything else we want to talk about? We have time. If you guys have subjects.
I mean, that's all that's on my
Yeah.
mind at the
All
moment.
right.
If anybody's got questions, happy
Yeah, if there's
to
any other questions,
answer
we
more.
have a few minutes. Let me see. I'm looking at the wrong notes. I'm trying to see if anybody posted anything in chat. It doesn't look like it. So I think we can call it a day here.
All right.
You guys have been awesome. It's such a pleasure having you guys on. I think mobile optimization is something that's, especially as more and more people are playing on the go, having the ability to have a game that's streamlined, runs smoothly, and makes just a fun experience really helps make those commutes or those drives, and even the plane ride, a lot better. So thank you guys so much for all the work that you guys are putting into the Unreal Engine for the optimizations.
Yeah, thank you, and yeah, certainly, I'm really excited to see what all the Unreal developers out there do with UE4 on mobile, especially with all of the optimization work that we've put into it recently. You should really be able to push those devices.
Yeah. We're one of the we just finished our game jam on Tuesday, and one of the categories was on the go, so it was decided for mobile. So I'm really excited to kind of jump into those games and see what they are. And,
Yeah, absolutely.
Well, thank you guys so much for tuning in to this week's Unreal Engine live stream. If you have any feedback for us, I'm dropping a link in chat right now. We'd love to hear your feedback, and make sure you fill out this survey. We are sending out T-shirts to people randomly for selecting or for giving us that feedback. So there's a link for that. Make sure you check in your area for Unreal meetups. There's a ton of people meeting all around the world. So visit meetup.com/pro/Unreal Engine. Make sure you submit your projects to the NVIDIA Edge program. And if you want to have your video as part of the demo where we start up, submit a 5-minute compressed speed development to us at community@unrealengine.com, and we'd love to show your game off here. And then make sure you guys follow us on social media at Unreal Engine. Thanks so much for tuning in. Thank you guys so much for joining today. It's been an absolute pleasure.
Thank you.
for having us.
All right, guys. We'll see you next week.
Bye.